Hello guys, welcome to the physics book. So last class we discussed about the prerequisites that we need to understand before moving into the chapter calorimetry. So of which we will just go for a quick recap. So first thing is energy of the universe is constant. What does this mean? So in this universe, energy can neither be created and nor be destroyed, which means whatever energy is already available in this universe, it will just get converted into different forms and we cannot create or we cannot destroy the energy. Can you give me an example? You can ask me the same question. Yeah, I can give you. Say for example, you are having a cup of coffee and you are letting it to cool for some time. For example, you are keeping the coffee for 1 hour to let it cool down. So what will happen is the energy in the body, particularly heat energy in that coffee, will slowly decrease. So which means like you can think of that, okay, energy is decreasing, so energy is getting destroyed, but that's not the case. So what is happening is this decreasing energy is simultaneously getting added up to the atmosphere. So atmosphere, I mean the air in which you are keeping the coffee, right, that is getting heated up, and that air, he is gaining this heat so that the energy is not getting disturbed at all, the overall energy of the universe. So energy of the universe still remains the constant. So the second point is like change in energy of the system is equal to change in energy of the surroundings, which is like a smaller derivative of the first equation. So what does this mean? This is the same thing that we discussed as an example, right? So this is the change in energy of the system, which is nothing but the heat energy that is lost by the coffee. So this alone will not be possible. Only if you keep coffee and it is losing heat. That is not possible in this universe as per law of physics. So what happens is somebody needs to gain this heat. So who is gaining this heat? This is the surroundings. Let's the plane goes. Okay. So now this coffee is giving up some amount of heat, and no way in this universe without somebody accepting that heat, this can reject that heat. So the air in which you have kept the coffee should be accepting this heat in order for this coffee to lose heat. If nobody, for example, if the air is not accepting that heat which the coffee is rejecting, the coffee will still remain with whatever the heat it is having, which means like the temperature of the coffee will never decrease if nobody is going to accept its heat. So that is this point, and this 2 points is very important in solving the problems. We need to go into the next lecture. We will be continuing with that lecture. So the third point is heat. So what does heat means? Heat is nothing but a thermal energy flow from one body to another body. The body can be a system or a surroundings. It can be like one system to another system, one system to surroundings, or surrounding to system. But to keep in mind, the heat energy can be transferred only between two entities. Either it should be between system and surroundings or surrounding the system. It cannot be happening within one system itself. For example, if you take a cup of coffee alone, this heat energy transfer will not be possible. As I said, somebody has to gain the heat or somebody has to accept whatever you are giving, then only you will be able to give them. So that policy works for heat energy transfer. The same case when you come to internal energy, it will be a little bit opposite. So we'll come to that later. But meanwhile, the fourth point, what is temperature? So temperature in last class, what we discussed is we had an example of bucket of water. The same way, like it's the average kinetic energy of all the molecules present in the body. And I made a simple mistake which was rightly identified by one of the subscribers and one of the viewers. He said like a kinetic energy is not having any directional constraint. It is exactly true. I made a simple mistake there. So kinetic energy is a scalar quantity, which means like it is just a number. It will not tell you like in which direction the body is moving. And also like how we can imagine that kinetic energy doesn't need any direction. That is true because kinetic energy is just a measurement of how haphazard a body is moving or how fast the body is moving. It is just that number. How fast plus how heavy. It depends on the mass as well as the velocity. So in a simple words, what you can assume a temperature is like average kinetic energy of all the molecules present in that body that you are considering to measure the temperature. And I am again repeating, it's not the directional property. The direction of kinetic energy is immaterial. Ideally speaking, kinetic energy doesn't have direction itself. So let me correct my mistake. So temperature, it's not directional kinetic energy, it's just kinetic energy and averaging out for all the molecules present in the body. So based on this temperature, you will be deriving out whether a body is hot or cold. So when somebody is asking you whether the body is hot or cold, you should be intellectual enough to ask them against what you need to tell them it's hot or cold. So what you will do is, if somebody is giving you a cup of coffee and asking you to tell whether it's hot or cold, what you need to ask them is like, against what I need to compare this coffee to tell it cold or hot. So, for example, if a body that you are considering is at a temperature higher than that of the surroundings, then that means it's a hot body. The body is lower in temperature compared to the comparison, then it is a cold body. The same thing which we discussed in the previous class. If you have any doubt, we can go to that video. I am putting that in the link as well. Now comes the internal energy, the interesting part, which we need to compare against the heat energy. So internal energy doesn't behave the same way as a heat energy, because internal energy is stored within the body, and heat energy is an energy transfer between two bodies. This can happen within one body itself. This needs at least two bodies. And internal energy is nothing but, for example, if you are eating a food, it is getting stored in your body. The same way, if a heat energy is given to this body, it can be stored in that body itself as internal energy. Internal energy, how a body is having internal energy then? If any body is having greater than 0 Kelvin, it will have internal energy by virtue of its temperature. So what is internal energy? Internal energy is an energy, but typically an energy stored in a body by virtue of its temperature. You can consider this as a thermal energy as well. But internal energy is not actually thermal energy. Internal energy is just energy stored within the body by virtue of its temperature.